welcome to this video once again. We are going to tackle these quantitative reasoning questions. Remember the rules I told you in the first video. Now we are going to see, I told you when you see a typical quantitative reasoning question, do not look at it as a very complex thing. Even when the drawings, the boxes, the patterns may look confusing. Now let's look at this. And also don't be tempted to assume the arrows matter. Sometimes the arrows are just there for decoration. They cannot tell the flow of the logic. So just look at the numbers. The main thing is look at the numbers and see what could form their relationship. Whether it's factors, it is sum, it is multiplication, it is division. Let's just look at this. We have the samples. We are given about 3 samples. Another thing is whatever logic you come about in one sample, you must test it with all the samples to make sure that that logic is valid. If it applies to the first sample and it does not apply to the next sample, that logic you cannot go with it because it is not the true logic. All right, let's look at this. I have 15, I have 9, I have 18, I have 6. With my experience, when I see a diagram like this diagram has 4 boxes. There is every tendency that 2 of them are going to be paired. 2 of them are going to be paired. So from experience, solving so many quantitative reasoning questions as a math teacher, I first look at the pairs to see if there could be any relationship between the pairs. I can do like this. Okay, let me pair these 2. I can first pair these 2 and pair these 2. If it doesn't work, I check otherwise. Now let's see. I have 9 and 15. There seems to be a common factor between 9 and 15. 9, there is a common factor of 3 and 3 here. Now I look at 18 and 6. There is also a common factor. So what could that be? What could that be? What could that be? Okay, common factors, but there is nothing else. So I look at addition. Remember I told you always start with the simplest operation like addition and subtraction. Now let me add the 2. 9 plus 15. 9 plus 15 will give me 24. 9 plus 15 will give me 24. Now let me also add these 2 numbers down. 18 plus 6. 18 plus 6 will also give me 18 plus 6 will give me 24. Wow, could that be the logic? That could be, but it is not enough yet because I haven't tested the other samples. I've just come about 24 and 24 as the sum of each of the 2 boxes. I have this pair of boxes adding up to 24. I have this pair of boxes adding up to 24. Now I quickly proceed to the second sample to see if that will hold. 7 plus 23. 23 plus 7 will give me 30. And 19 plus 11. 19 plus 11, if I add 1 to this, that's 20 plus 10. 19 plus 11 will give me 20. Wow, that one too is correct. Then I go on to the third sample. Sometimes the logic may be applicable to the first sample, the second sample, and it is not applicable to the third sample. All right, so I was able to determine that 23 plus 7 is 30, and also 19 plus 11 is 30. Oh, not 20, sorry, is 30. So I check to see if that logic applies to the third sample. So 9 plus 6. 9 plus 6 gives me 15. 11 plus 4 gives me 15. Wow, I am very sure that that is the logic or rule applicable to this question. So I can proceed now that I have tested that logic on the 3 samples and it is valid. So I can quickly proceed to the answers. Now, the rule that applies here is addition. And if there is addition, the reverse of it is subtraction. Take note because when you are given a different box, you may be required to do subtraction instead of addition. So wherever you see addition as the link, the reverse of it will be subtraction. Now, let's look at number 1. So in this case, what I will do is first to add the 2 pairs The pair that I have, the complete legs. I have this pair and this pair. This pair I have the two boxes. So 19 plus 13. I'm going to do 19 plus 13. This is 12. I carry over 1. So this is 32. It means 7 plus this box should also give me 32. So how do I arrive at 32? It's simple. Since the sum of these is equal to the sum of these. So I will quickly say 32 minus 7. Remember, I told you the reverse of addition is subtraction. So 32 minus 7 will give me the number that is supposed to be in this box. And 32 minus 7 is 25. So 25 is option C. 25 is option C. Question number 2, still following the rule. I have in this one, the upper pair is complete, 14 and 41. So I say 14 plus 41. 4 plus 1 is 5. 1 plus 4 is 5. And that gives me 55. So if I have 55 here, it means for me to get this simply means 35 plus what will give me 55. So I can do 55 minus 35, and that will give me 20. So that means this missing box is 20, which is B. I come over to this. The same thing. The down pair is complete. I have 25 and I have 7. So I quickly add the two of them. 25 plus 7. 25 plus 7 will give me 32. So 32 minus 32 should give me this. And so 32 minus 32 is 0. And that's option A. I hope with this you have learned at least one or two things that will help you to tackle your quantitative reasoning questions. Follow us in this series and you are going to learn a lot of tricks on how to crack quantitative reasoning questions. Even as a child, as a parent, as a math teacher, you are going to learn a lot. Thank you.